Welcome guys to our channel. In today's video, we are going to solve two integrations which will cover nearly all techniques of integration for JEE. If you are new to our channel, subscribe to our channel for more videos on the topics of JEE Maths. So this is our first problem here. We are asked to find the value of this definite integral. Okay. The value of this definite integral is k log 2 where k is a real number. We have to find the value of k. Okay. So at first, this integral looks very scary. Terms like log to the power 4, log square, and here this power half, right? The square root. That makes this integral appear very scary and very dangerous. But we will decode the integral in step by step. Okay. So let's try this. First of all, if we try to notice here a thing that this term log to the power 4, right? This term here inside log is e times 1 plus tan x times 1 plus tan square x divided by 2 tan x. Okay. And here we have also the same term with power 2. Log of e into 1 plus tan x times 1 plus tan square x divided by 2 tan x, this square. Okay. And we have this term here, this term log 1 plus cot x 1 plus tan square x divided by 2e, this raised to the power 4 and here raised to the power 2, right? So if we call this a to the power 4 and this as b to the power 4, this term is minus 2 a square b square, right? So this thing we can simplify as a square minus b square whole square, right? Because a square minus b square whole square is a to the power 4 plus b to the power 4 minus 2 a square b square. So we can simplify this thing as integral 0 to pi by 4, then this log e into 1 plus tan x times 1 plus tan square x divided by 2 tan x this squared minus log this 1 plus cot x times 1 plus tan square x divided by 2e, this square. Okay, this thing whole square into half. That means what we have to take? We have to take the mod here, because we know root of x square is mod x, right? Root of x square is not simply x or minus x, it is simply mod x. Okay, so we have to calculate this modulus first, right? So if we remove the square root here, we get this modulus sign. So this thing is some a and this thing is some b, right? Or maybe we can call this a square and b square. So we have to calculate a square minus b square modulus. So let us check a minus b here. A minus b will be what? A is simply our log of this term and b is simply log of this term. Okay. Square is not included in a or b. A and b are simply the logarithmic terms. So a minus b will be log then e into 1 plus tan x times 1 plus tan square x divided by 2 tan x. Okay. This minus log of this. That means log of this divided by this, right? That means into 2e divided by 1 plus tan square x times 1 plus cot x, like this. Okay, now we can actually cancel this 1 plus tan square x here, and 1 plus cot x we can write as 1 plus 1 by tan x. That means 1 plus tan x divided by tan x. So tan x will be here and this cot x becomes tan x. Okay, so this 1 plus tan x gets cancelled and tan x gets cancelled. Okay, also we can say here 2 gets cancelled, so we get a minus b is log of e square. So this is simply equal to 2, right? Now let us calculate this a plus b here. A plus b, if we calculate, we can say this will be simply log of e into 1 plus tan x times 1 plus tan square x divided by 2 tan x times this 1 plus tan square x times 1 plus tan x divided by tan x and then 2e. Okay, so e gets cancelled and we get log of this squared, right? So we have here a plus b equal to log of this 1 plus tan x times 1 plus tan square x divided by 2 tan x, this whole square. Okay, but this thing we can again write as 2 log mod of 1 plus tan x, then 1 plus tan square x, right, divided by 2 tan x. And what will be this modulus here? This modulus will simply open with positive sign. Why? Because 1 plus tan x, this thing is positive, right, in the given interval 0 to pi by 4. And also this thing 2 tan x divided by 1 plus tan square x we can write as sine 2x. 1 by sine 2x, right? So this thing is also positive in open 0 to close pi by 4. So we can say this thing will simply open with positive sign like this, right? So we have got this integral as integral 0 to pi by 4. So we can write this mod of a plus b, a minus b, then dx. And mod of a minus b is 2 simply. So 2 outside. Then if we calculate this, okay, so a plus b is our 2 log 1 plus tan x divided by sine 2x. Okay, now we have to check this term inside this log. Okay, if the argument that we are passing in the log function is less than 1, that means this mod will open with negative sign, right? And if the argument that we are passing here 1 plus tan x by sine 2x, this is greater than 1 for this interval, that means we have to open the mod with positive sign. So let's check in this interval 1 plus tan x and sine 2x. Okay, let's check this function whether the ratio of these two function is greater than 1 or less than 1. So 1 plus tan x will lie between, this will lie between 1 to 2, right? We are taking open bracket at 0 because at 0 this term inside log is not defined. Okay, and then we have sine 2x, so this belonging to the interval 0 to 1, right? And observe a thing that both of these functions are increasing, right? Tan x, 1 plus tan x graph looks something like this, and sine 2x also looks something like this. Okay, in 0 to pi by 4 I am sketching, so in 0 to pi by 4 it may be something like this. Okay, and in 0 to pi by 4 the graph of sine 2x will look something like this. So these functions are increasing, that means when we are comparing these two functions 1 plus tan x and sine 2x in this interval 0 to pi by 4, so we can say this will be closed at 2 and closed at 1, open 0 to close pi by 4. We can say 1 plus tan x will always be above sine 2x. Okay, that means 1 plus tan x will be greater than sine 2x for this interval. That means 1 plus tan x divided by sine 2x is always greater than 1. So we can open this modulus sign with positive sign. Okay, so we get 2 times integral 0 to pi by 4 a plus b dx. That means 2 into 2, so 4 outside, then log of 1 plus tan x divided by sine 2x we can split as 1 plus tan x minus log of this sine 2x dx. Okay, like this. So we have to only calculate this integral to get our answer. Okay, so let us evaluate. Now these two integrals are again some important integrals. We can directly remember their answer because many questions we can find which require the value of this integrals. Okay, so you may need these values to solve those questions in a faster way. So let us calculate this. So let's call this I1, let's call this I2. I1 is integral 0 to pi by 4 log of 1 plus tan x dx, right? So we have to apply King's property here to evaluate this integral. So we can write this integral 0 to pi by 4 log of 1 plus tan of pi by 4 minus x. So that means tan of pi by 4 minus x will be what? It will be 1 minus tan x divided by 1 plus tan x, okay, dx. So if we calculate this, we get it is equal to I1 is equal to integral 0 to pi by 4 log of 2 divided by 1 plus tan x dx. Now we have to simply split this, okay, this log. So integral 0 to pi by 4 log 2 dx minus integral 0 to pi by 4 log of 1 plus tan x dx. Now this thing is again I1. Okay, so this thing is I1, that means I1 times 2 is equal to this integral. Okay, so I1 is half times this integral is pi by 4 log 2, so pi by 4 log 2. Okay, so our I1 comes out to be pi divided by 8 log 2, right? So this is our I1. Now we have to calculate this I2. Okay, so I2, let us calculate. I2 is integral 0 to pi by 4 log sine 2x dx. First let us simplify this integral to 0 to pi by 2. Okay, because that integral is a more standard value to remember. So we can write this as integral 0 to pi by 2 log of sine t dt times half. Okay, I just substituted 2x equal to t in this integral. Okay, now this value integral 0 to pi by 2 log of sine t dt, this value is, we should remember, it is equal to minus pi by 2 log 2. Let us derive this by the way to understand things better. So integral log of sine t dt from 0 to pi by 2, this we can also write as integral 0 to pi by 2 log of cos t dt, right, by the King's property. So let's call this I dash. So I dash is this, right? So 2I dash will be what? We simply add this two integrals here. Okay, so we get integral 0 to pi by 2, then log of sine t cos t dt. Okay, and integral 0 to pi by 2, this we can write again as log of sine 2t divided by 2, right? This sine t cos t, if we multiply and divide by 2, we get sine 2t divided by 2. So log of sine 2t dt minus integral 0 to pi by 2 log 2 dt. We split the log term here. Okay, now observe a thing here, that we can write this as integral 0 to pi by 4 times log of sine 2t dt times 2. Okay, because this integral, we can say this function log of sine 2x is symmetric about the line x equal to pi by 4. So if we integrate from 0 to pi by 4 and integrate from pi by 4 to pi by 2, both the integrals will be same. So we multiplied it with 2, right? Now this thing is what? This thing is again our half times I dash, right? So this overall will be I dash. So we get one I dash will be cancelled from here. Okay, so we get I dash equal to this integral, right? This integral is simply minus pi by 2 log 2. So I dash is minus pi by 2 log 2. Okay, so this is again a standard value you should remember, because in many questions this value is directly used. Okay, so if we calculate the value of I2 from here, I2 is half times this, so minus pi by 4 log 2. Okay, so from here we have to simply calculate the value of I1 minus I2. So I1 minus I2 will be pi by 4 plus pi by 8 times log 2. That means this will be 3 pi by 8 log 2, right? And we also had this 4 here outside this integral. That means our final answer will be I equal to 4 times this I1 minus I2. That means this will be 3 pi by 2 log 2. Okay, so 3 pi by 2 is our k here, right? So k is what? The value of k is equal to 3 pi by 2. And as this is a numerical type question, so we have to fill the answer up to 2 decimal places. That means 3 into 1.57 almost, right? Pi by 2 is 1.57. Again, we have to remember. So this will be 1, then this will be 4.71. Okay. So our correct answer in this case will be 4.71. Okay. Okay, so this is our second question. This question is actually a very lengthy question. Okay, this question will help us to revise almost all the concepts of indefinite integration. Okay, so let us solve this. First of all, don't be scared by just the look of the question. We should try to simplify the expression first, okay? To understand the integral, what we have to integrate. Let us first simplify. Now we can observe a very interesting thing in this integral, that this thing here, this expression, if we try to look into this thing, if we call this some a, okay, this thing is nothing but a square, and this thing is nothing but a cube. You can verify it yourself by multiplying this terms, this with this, and then calculating this term. You can get that this term is a cube, this is a square, this is a, okay. That means this is what, a cube t cube, which is 80 whole cube, okay. So 80 whole cube plus 3 times 80 whole square times 1 plus 3 times 80 into 1 square plus 1 cube, okay. Now this is what it is, simply 80 plus 1 whole cube, right? And this thing we can also verify, that if we call this a here, or let's call this b, okay. So b here, this is nothing but b square, and this thing is nothing but b cube, okay. So this thing is what, bt whole cube minus 3bt whole square plus 3 times bt into 1 square minus 1 cube, okay. This is nothing but bt minus 1 whole cube, right? So these terms are nothing but cubes, and when we raise them to the power 1 by 3, we get exactly 80 plus 1 and bt minus 1, okay. So let us calculate this. So our integral simplifies to this 80 plus 1 is simply root 2 plus 1 times t plus 1, right? And then we have this as root 2 minus 1 times t minus 1, okay. Now divided by, we have to simply add the powers of 1 plus t cube, okay. So 1 plus t cube to the power 1 by 3 is here, and again we raise it to the power 1 by 3. That means what will be the final power of 1 plus t cube here, 1 plus t cube to the power 1 by 9, okay. And here we also have 1 by 9, that means 1 plus t cube whole to the power 2 by 9, and they both are in the denominator, so we can say the powers will add up. That means 1 plus t cube whole to the power 16 by 9 plus 2 by 9, that is 18 by 9, which is 2, okay. So that means 1 plus t cube whole square dt. Now we have to simply calculate this, okay. Integral 0 to 1, then we have here, if we calculate, this is t square minus root 2 plus 1 plus root 2 minus 1, so this is minus 2t. Then we have minus 1 divided by 1 plus t cube whole square dt, okay. So we have to calculate this integral to evaluate our options. So let's calculate this. So I is integral 0 to 1 t square minus 2t minus 1 divided by 1 plus t cube whole square dt, okay. Now how to solve this? The thing is, we can factorize this denominator, right? Because 1 plus t cube we can write as t plus 1 times t square minus t plus 1, right? So this becomes integral 0 to 1 t square minus 2t minus 1 divided by t plus 1 whole square times t square minus t plus 1 whole square dt, okay. So as we factorize this into linear and quadratic factors, we can use the concept of partial fractions to evaluate this integral, okay. So we have to first apply partial fractions in this function. T square minus 2t minus 1 divided by t plus 1 whole square times t square minus t plus 1 whole square. So this thing we can write as a divided by t plus 1 plus b divided by t plus 1 whole square. Plus we have to consider something, a linear form in the numerator for this quadratic terms, okay. So we can take, let's say, ct plus d divided by t square minus t plus 1 and plus another linear factor here, et plus f, let's say, divided by t square minus t plus 1 whole square, okay. So we have to calculate all these 6 variables to get the partial fractions. So we can find this. We take all this in the right hand side. So t square minus 2t minus 1 equal to a times t plus 1 times t square minus t plus 1 whole square plus b times t square minus t plus 1 whole square plus ct plus d times t plus 1 whole square t square minus t plus 1, right, plus et plus f times t plus 1 whole square, right. Now we can easily find the value of b from here, from this equation, because if t equal to minus 1, let's say we put, this factor vanishes, this factor vanishes, this factor also vanishes. Okay, so we get from here b equal to, or b times, this will be 1 plus 1 plus 1, so 9, 9b equal to, this will be 1 minus 2 minus 1. Okay, so minus 2, that means b equal to minus 2 by 9. Okay, so we are left with 5 more variables to solve. Now to solve this remaining 5 variables, we can expand this expression. Okay, so we get some coefficient of t to the power 5, because maximum it will go up to t to the power 5, right. This will give some t to the power 4 terms, and multiplied with it will give us t to the power 5 term. Okay, so t to the power 5, t to the power 4, t cube, and then t square, then t, and then some constant term. Okay, equating the coefficients of these 6 terms in both LHS and RHS will give us 6 independent equations, and we have to solve them to get the values of these 6 variables, right. So one variable is already determined, rest 5 we have to calculate. So this thing I am leaving for you, do calculate it yourself, and the final answer I am writing here. What I got a equal to 0. Okay, b equal to this thing minus 2 by 9, c equal to again 0, d equal to 2 by 9, then I got e equal to minus 2 by 3, sorry, 2 by 3, and f equal to minus 1. Okay, this values I got. I hope you will be able to calculate it yourself, okay, using the expansion. So our integral becomes, let's call this I. Okay, so I becomes integral 0 to 1. Then we simply decompose this, so this term vanishes, so b is minus 2 by 9. Okay, minus 2 by 9, 1 divided by t plus 1 whole square dt. Then we have, so this term becomes 2 by 9 times 1 divided by t square minus t plus 1. Okay, so plus integral 0 to 1, this 2 by 9 times 1 divided by t square minus t plus 1 dt, right, plus we get from this 2 by 3 times t minus 1, so 2 by 3 t minus 1 divided by t square minus t plus 1 whole square dt, integral 0 to 1. Okay, so we have to calculate this integrals. So let's call this I1, let's call this I2, let's call this I3. So I1 and I2 and I3, let us calculate separately. Okay, so I1 is simply, we can say it is integral 0 to 1 dt divided by t plus 1 whole square. That means this simply becomes 2 by 9, 1 divided by t plus 1 with limits from 0 to 1, right. So this becomes half minus 1, so minus 2 by 9. Then I2 becomes integral 0 to 1, sorry, this thing becomes, I think, multiplied by half, this becomes minus 1 by 9. Okay, so this thing integral 0 to 1 dt divided by t square minus t plus 1, we can also simplify. This will be 2 by 9 integral 0 to 1 dt divided by, this will be t minus half whole square, right. This thing we can write as t square minus t plus 1 by 4 plus 3 by 4, right. And this thing is a perfect square, right, which is t minus 1 whole square plus, then we have root 3 by 2 whole square. Okay, this thing is, we can easily calculate by using the formula of dx divided by x square plus a square. Okay, The integral of dx divided by x square plus a square is 1 by a tan inverse x by a. So this becomes 2 by 9 times 1 by 8, so 2 by root 3 tan inverse, we have t minus half divided by root 3 by 2, okay, with limits from 0 to 1. So this thing becomes 4 divided by 9 root 3. Then this becomes pi by 6 plus pi by 6. That means simply 2 into pi by 6, which is pi by 3. So 4 pi divided by, this becomes 27 root 3. Okay. So I2 becomes this. Now we have to calculate this I3. I3 is the biggest problem here. Okay. Because we have a quadratic squared in the denominator. So let us see how to handle this type of questions. So we have here I3 integral 0 to 1 2 by 3 t minus 1 divided by t square minus t plus 1 whole square dt. Okay. So first we have to express this in terms of the derivative of this function t square minus t plus 1. Okay, in the numerator part we have to express in terms of the derivative of this t square minus t plus 1 plus some constant. Okay, so our main idea is to express this 2 by 3 times t minus 1 as some constant time the derivative of this function here. This function is t square minus t plus 1, so derivative will become 2t minus 1 plus some b. Okay, let's call this a dash b dash. So here we can compare the coefficients of t and the constant term. Okay, so from here we can say a dash equal to 1 by 3. Okay, and b dash minus a dash is equal to minus 1. That means b dash is equal to minus 2 by 3, right? So our integral becomes integral 0 to 1 a dash times 2t minus 1. So a dash is 1 by 3. So then 2t minus 1 dt divided by t square minus t plus 1 whole square. Okay. Then we have b dash. So b dash is minus 2 by 3. Then we have integral 0 to 1 dt divided by t square minus t plus 1 whole square. Okay. Now this part is very easy to calculate. This is some f dash divided by f square. Okay, f dash divided by f square. The integral of this is simply minus 1 by f. Okay, so we can calculate this 1 by 3 times this 1 divided by t square minus t plus 1 and limits inverted. So 1 and 0. That means this becomes simply, if we calculate 1 by 3, 1 minus 1. So this thing becomes simply 0. Okay, and then we have to calculate simply this thing. So this becomes minus 2 by 3 integral. Now see, we can express this t square minus t plus 1 as some perfect square plus something constant. Okay, so let us express this. We saw that we can express this in terms of t minus half whole square plus root 3 divided by 2 whole square, right? This integral. So this, if we do a little substitution here, we put t minus half equal to some x. Okay, so our dt becomes dx. So this becomes minus half to half integral dx divided by x square plus this root 3 by 2 whole square. Okay, so this part is basically 2 times integral 0 to half, right? Because this is a even function, so we can multiply with this 2 here. Okay, and this thing we have to take whole square also. Now the question is how to calculate this integral. Okay, we know the formula of integral dx divided by x square plus a square, but how to calculate the integral dx divided by x square plus a square whole square? Okay, or anything like that, x square plus a square whole to the power n. Let's say n is any natural number. How to calculate this? Let us see here the process. The process is basically based on the concept of Leibniz rule. Okay, the Leibniz rule of differentiation under integral sign. I already made a video on this Leibniz rule. You can check out that video if you don't know about Leibniz rule. There I discussed about this type of parametric differentiation. Okay, we discussed there how to differentiate under integral sign with respect to a variable parameter. Okay, so let us use this concept. So we already know this, right? Integral dx divided by x square plus a square, this integral is equal to 1 by a tan inverse x divided by a, right? Plus integration constant, right? Now we need this power here, right? Whole square, this whole square. How to create this? How can we create this? To create this, we need to differentiate this integral with respect to this parameter a, right? Because when we differentiate both sides with respect to this parameter a here, where a is non-zero, okay, a is non-zero, we are saying. So if a is non-zero, we are differentiating this parameter. So then we get integral. Then differentiating this will give us 1 divided by x square plus a square whole square with a negative sign times derivative of this a square. So 2a here dx, okay, equal to, then differentiation of this. So this will be minus 1 by a square tan inverse x by a, right, plus 1 by a times we have 1 divided by this x square by a square plus 1 times derivative of this x by a with respect to a here. Okay, that means minus x divided by a square, like this, and then differentiation of this constant is 0. So minus sign gets cancelled overall from this equation. We get integral dx divided by x square plus a square whole square is equal to, if we take this 2a in the right hand side, we get 1 by 2a cube tan inverse x by a, plus this will be, if we simplify this, so this thing becomes x square plus a square divided by a square, so a square will be in the numerator. Then we get x square plus a square here, and a square gets cancelled as a is non-zero. Okay, and then we have this 2a multiplied with this a here, so 1 by 2a square times x divided by x square plus a square. Okay, this is our answer. So we have to simply put the limits half and 0. Okay, so let us put this. We get our I3 equal to minus 4 by 3 times integral 0 to half. So we have to put the limits. So a is root 3 by 2 here in our case. Okay, so 2 times this will be 3 root 3 divided by 8 times tan inverse. This will be x divided by a, so x divided by root 3 by 2 with limits from 0 to half. Okay, plus here it will be 1 divided by 2 into, this will be 3 by 4, that means 3 by 2. Then here x divided by x square plus 3 by 4 with limits from 0 to half. So this thing becomes minus 4 by 3. So this thing becomes, simply we can say 4 divided by 3 root 3 times tan inverse 1 by root 3 is pi by 6. Okay, plus this thing is 2 by 3 times half times this will be 1 divided by 1. So this things finally becomes minus 4 by 3 times this will be 2 by 3. Okay, so 2 by 9 root 3 pi, and then plus 1 by 3. This is our I3. So we got I1 equal to what? I1 will be minus 1 by 9, right? Minus 1 by 9. I2 equal to 4 pi divided by 27 root 3. I3 equal to this thing. This will be minus 8 divided by 27 root 3 pi. Then we have minus 4 by 9, right? Okay, let me correct one thing here. I actually calculated this b variable here to be equal to 2 by 9. Okay, so this will be 2 by 9. So this was my mistake. Okay, let me correct this. So b is coming out to be 2 by 9 and d is coming out to be minus 2 by 9. Okay, so from here we can say this will be minus 2 by 9 and this will be plus 2 by 9. Okay, so these things will be plus 1 by 9. Okay, and this thing will become minus 4 pi divided by 27 root 3 minus, and then here minus. Okay, now let us jump to our final calculations here. So I1 plus I2 plus I3 will be, if we correct this will be plus, this will be minus. So the sum of all these three integrals will be minus 3 by 9, then minus 12 pi divided by 27 root 3. Okay, so this is our I. So we have to calculate what? We have to calculate the value of 3i plus 1 whole square, right? So 3i plus 1, 3i plus 1 will be, if we calculate this will be 3 times this will be minus 1, minus 3 times this will be 12 by 9. So we can cancel this 3 here, 4 and this 9. Okay, so minus 4 pi divided by 3 root 3, and then we have also a plus 1. That means this becomes minus 4 pi divided by 3 root 3. Okay, so 3i plus 1 whole square will give us this whole square. Okay, that means this becomes 16 pi square divided by, this will become 27. So let us check the options here. So 27 means option B will be our correct option in this case. Okay, so we can see how this one question was able to help us revise so many concepts at once. Okay, this concept of simplification regarding the identities, and then in the second step we had to calculate the partial fraction, and this part I have left for you. Okay, we have to solve for 5 or 6 variables, so this also demands a huge amount of work. Then we have this integrals here. This is standard integral and this is again a standard integral, but this integral was a bit off standard. Okay, so we had to think about this approach, differentiation under integral sign, and then we arrived at our final answer. Okay, now this question you can try yourself and post the answer in the comments. Okay.